Hey everybody, just want to welcome you to week 9, module 9 for ME 171, design of elements. So within this module here, we're covering two different chapters. We're looking at chapter 7 and chapter 8, dealing with impact and fatigue. So some bookkeeping items for this week. We have your quiz number 9. This has been posted to Blackboard and will be due on Friday the 2nd by 4 p.m. You also have your homework number 4. This is assigned on Monday the 29th and posted to Blackboard, and this will be due the following Monday the 5th by the end of the day. So just a reminder, I do have my office hours scheduled for Thursdays after class from 11:30 to 12:30. Now, if you're not able to make it during this time, please send me an email, a message, or a chat on Teams, and I'll find a time that does work. Now, just a reminder, also, the TA does have office hours scheduled for Wednesdays as well. And this is for 10 a.m. to 11:30 a.m. for an hour and a half. And this is a great opportunity if you have any questions related to homework, grading, exams, because the TA is the one who'll be grading those. Within our Module 9, we're going to take a look at impact and fatigue. So an overview of what we're going to be looking at in this module here is we're going to go through Chapter 7, taking a look at impact loading, which is also known as shock, sudden, or impulsive loading. Now we can divide impact loads into 3 different categories, and we'll sort them in the order of increasing severity. So number 1, we have rapid moving loads of essentially constant magnitude. This is something that's produced by like a vehicle crossing over a bridge. 2, we have a suddenly applied load, such as those of an explosion or from a combustion of an engine cylinder. And 3, we'll take a look at direct impacts loads. Now these are produced as a pile driver, drop forge, or a vehicle crash. Now we're also going to go through Chapter 8, taking a look at fatigue. So a fatigue fracture begins with a small, usually a microscopic crack at a critical area of a high local stress. Now this is always a geometric stress razor, and additionally, small material flaws or pre-existing cracks are commonly involved. So some objectives within this module here. Within this chapter, we're going to take a look at stress and deflection caused by linear and bending impact and torsional impact. We'll take a look at the effect of stress razors on impact strength, go through some fatigue strengths, talk about the effect of mean stress on fatigue strength, look at the effect of stress concentration, then go into some fatigue life prediction with randomly varying loads, take a look at different surface treatments, talk about some fatigue crack growth, and then at the end here, look at some general approach for fatigue design. So relating to our textbook here, this is going to be Chapter 7, Sections 1 through 3, from 1 through 4 for our Module 9.1, and Chapter 8, Sections 1 through 17 for our Module 9.2. So taking a look at Module 9.1, this is where we're going to look at impact. So we're going to talk a little bit, just go through an introduction to what impact is, talk about the stress deflection caused by linear and bending impact and torsional impact, and then to get into some of the effects of stress razors on impact strength. So within this module here, we'll go over some of the governing theory, look at some of our key equations, talk about some practical applications utilizing this theory, and then go in through and do some problem solving. So with Module 9.2, we'll look at the topic of fatigue. So objectives within this module here, we'll take a look at some fatigue strength, go through some of the estimated fatigue strength for completely reverse loading, talk about the effect of mean stress on fatigue strength, go through the effects of stress concentration, and in particular we're going to go with completely reverse loading and then also with mean plus alternative loads. Then we're going to talk about fatigue life prediction with randomly varying loads. Talk about different types of surface treatments, get into some discussion on thermal and chemical surface hardening treatments, then talk about some crack growth from fatigue, and then get into our actual fatigue design. So again, within this module here, we're going to spend some time going through this governing theory right here, take a look at our key equations, some practical applications related to research, and then go through some problem solving together.